Over the previous 10 years, there has been growing excitement within the automobile sector regarding a forthcoming transformation. Mercedes-Benz took the entire industry by surprise through the creation of a cutting-edge powertrain. What sets it apart? Is it ready for manufacturing yet? Allow me to shed light upon the radical axial flow engine from Mercedes-Benz, which has captivated the industry. Chapter 1: A look back at history. Mercedes-Benz enjoys a prominent position in automotive history, being responsible for crafting the very first true automobile, the Benz patent motor car, model number 1, back in 1886. Ever since, it has served as a representation of luxury and status, making every one of us harbor aspirations of owning a Mercedes someday. But it's not merely about the rich heritage. Mercedes continually strives to push boundaries and innovate. Quite surprisingly, the initial self-driving vehicle did not originate from Tesla, but rather from a prototype named Mercedes-Benz W114-250 Automatic, dating back half a century. Isn't that fascinating? When discussing advancements, let's remember that the inaugural actual supercar did not emerge from Ferrari or Lamborghini. Instead, it was the Mercedes-Benz 300 SL. In my view, the 300 SL exudes sheer beauty. Its aesthetics encapsulate sophistication blended with sportiness. And those iconic gull-wing doors? They are nothing short of a masterpiece. Just like in the past, Mercedes-Benz aims to lead the automotive industry into the future. Dedication and innovation are the cornerstones of the brand. After years of research and development, they have once again innovated. So, let's delve into and comprehend the workings of this new engine, born out of sheer dedication. Chapter 2: Competitors and Motives. Mercedes-Benz left the automotive world in awe by revealing its axial flow engine. Although electric, this innovation significantly differs from the conventional electric motors we are familiar with in Tesla vehicles and older Mercedes models. The primary distinction lies in the internal layout. The axial flow engine aligns the space between its rotor and stator parallel to the axis of rotation, unlike the traditional radial space motor, where the magnetic flow between rotor and stator is perpendicular to the axis of rotation. This structural difference has earned the axial engine the nickname pancake motor due to its slim profile, contrasting with the cylindrical shape of radial motors. Historically, the industry has favored radial engines due to their cost-effectiveness in mass production, featuring fewer magnets than pancake motors. However, axial flow engines offer significant advantages. They generate considerably higher torque, thanks to their rotating element being located on the outer diameter, yielding up to 40% more torque compared to an equivalent radial engine. For electric vehicles, torque is crucial, and having it in abundance is always advantageous. Another remarkable aspect of axial engines is their superior cooling capacity, ensuring they do not overheat even after prolonged use. This is where YASA comes into play, a British manufacturer specializing in axial flow engines. Established in 2009, the company has been researching and developing this technology for years. In 2015, its engine powered an electric vehicle that set records at Pikes Peak climb. This accomplishment did not go unnoticed, sparking the interest of Ferrari, which later collaborated with YASA on a secret project. 9 years later, this partnership culminated in the Ferrari SF90 Stradale, the world's first hybrid supercar. The SF90 is equipped with 3 YASA axial engines and a potent twin-turbo V8 4.0, totaling an impressive 1,000 horsepower. However, the SF90's steep starting price, exceeding $500,000, limits its production. Recognizing the untapped potential of YASA, Mercedes-Benz made a strategic move. In 2021, it acquired YASA, funding the development of axial flow batteries tailored to the manufacturer's needs. This means that soon, axial flow motor technology will be accessible for regular vehicles. And, as is typical of Mercedes, it will spearhead its commercialization. The big question on everyone's mind now is, when will this technological marvel hit the production line? The anticipation might be exhilarating, but given Mercedes' track record, expectations are running high. Chapter 3: Global Impact. Mercedes-Benz, a globally recognized brand, has taken a monumental step in automotive evolution. It recently announced the commencement of production for an innovation, the Axial Flow engine. To commemorate this milestone, it unveiled the Mercedes-Benz Vision 111. This vehicle is not just a car, it's a declaration of intent from the brand. It's as if Mercedes looked back at its illustrious past, specifically at the legendary Mercedes-Benz C111, and decided to pay homage to it. The C111, in its time, was a trailblazer, and now, the Vision 111 promises to continue that legacy. What stands out most in the exterior design? It's hard to miss the gullwing-style doors, a feature long associated with elite sports cars. Many enthusiasts have hoped to see this in modern Mercedes. Add to that the vibrant orange hue, reminiscent of the C111, and we have a visually striking combination. The interior, on the other hand, is a revolution in itself. Imagine stepping into a vehicle and feeling like you're in a spaceship. That's the promised experience. Silver-finished seats with intricate details transport occupants into an almost intergalactic experience. And one wonders, could this be a car of the future that Rick Deckard from the Blade Runner series would choose? Mercedes-Benz takes pride in presenting the groundbreaking Vision 111, which pushes boundaries by offering a luxurious lounge-style interior within a sports car. Combined with remarkable power, this vehicle aims to redefine driving experience. Although specific figures remain undisclosed, Mercedes teases exceptional performance comparable to rival sports cars, thanks to its cutting-edge Axial Flow engine. Axial Flow engines offer several advantages, including reduced overall vehicle weight due to their compact size. Lower mass paired with anticipated power results in enhanced agility, enabling smooth navigation around corners while maintaining stability. Weight distribution and low centers of gravity contribute significantly to the unparalleled handling capabilities of the Vision 111. Furthermore, the efficiency of axial flow engines ensures minimal strain on the powertrain during operation. As interest grows in self-sufficient electric vehicles, this announcement brings excitement to those awaiting advancements in EV technology. Limited availability adds to the appeal of the Vision 111, with only 111 units planned for production, ensuring rarity and desirability among collectors and enthusiasts alike. Undoubtedly, Mercedes demonstrates commitment to innovation and customer satisfaction by listening to consumer needs and setting trends accordingly. While axial flow engines remain exclusive to the Vision 111 currently, Mercedes-Benz EQS models continue utilizing conventional power plants, showcasing strategic timing for technology implementation. Exploring the challenges surrounding mechanical engineering and the axial flow engine reveals unique characteristics. Its distinctive stator and rotor configuration create dual air gaps, increasing performance control complexity compared to radial counterparts. Initial operation may produce increased noise, vibration, and roughness. However, this drawback becomes a significant advantage. Without a shaft connecting the stator components, production requires substantial modifications,